Hello! Hello to all you science fiction fans and all you science people in general. Right now, I'd like to say that I'm very disappointed that I will not be attending the Comic-Con convention that is going on right now. I was hoping to attend, but I just don't have the time and money right now to do it. I've been to other conventions, I've been to Star Trek conventions and other such fun conventions, but not a Comic-Con convention, and for that I'm rather disappointed, because I was really hoping to make it. But aside from that, I have time to make these videos instead. Now, some of you people on YouTube, and you people know who you are, you like to take science fiction and you like to talk about the possibility of it being applied to real life. After all, that's what real science is all about. Coming up with stuff to make life easier, to enable us to do more. In the old days, if you wanted light, you had to go around lighting all these candles and take a lot of time doing it. Nowadays, you just flick a switch and you have lights. Because we have discovered how to harness electricity and how to use it for various purposes, such as lighting up rooms. Makes life a bit easier. But anyway, I'd like to talk in this video about lasers and the possibility of using lasers as a weapon, or for any other use for that matter. Now, from what I understand about lasers, this is one of the biggest problems we've got. That a laser, which is a form of energy, of course, but whenever we use energy, whenever we convert energy from one form to another, something happens. You know, energy has various states. You've got potential energy, kinetic energy, etc., etc. Now, to explain what happens whenever energy switches forms, I'm going to use something very simple. I'm going to use a rubber band. And with this rubber band, I'm going to do something that most of us have done as children. I'm going to shoot it. So here I have the rubber band, and I draw it back. Now, with this rubber band being drawn back like this, it has got potential energy in it. Right now, by holding this rubber band back, by pulling it back, I put potential energy in it. So there's this potential energy that's built up in the rubber band right now. And now I will shoot it. Now, what just happened, that potential energy that was in the rubber band, when I shot the rubber band, I released it. That potential energy was released and it became kinetic energy. So when the rubber band went flying, that was kinetic energy. So there you have an example of potential energy being converted into kinetic energy. Now, some people might think that all of the kinetic energy I had in that rubber band, 100% was turned into kinetic energy, that 100% of the potential energy became kinetic energy. That is wrong. Not all of it. Less than 100%. Some of that energy gets wasted. It gets wasted in the form of heat. When I released that rubber band, only so much of that potential energy went into shooting it out. Some of it went into heat. The rubber band, friction as it went flying through the air. So in other words, some of that energy is wasted in the form of heat. To put it in simple terms, whenever we use energy, we pay taxes. We pay taxes on the energy that we use. Because some of it's wasted. Even when you drive a car and you burn the gas, not all of that goes towards turning the wheels. You know, it gets used up as heat. That's why we have to have cooling systems in our car. We pay taxes. Whenever we use energy, we pay taxes. And with lasers, from what I do know about lasers, we pay heavy taxes whenever we run lasers. That 10%, if as much as 10% of the efficiency with lasers goes into the energy that our source, if as much as 10% goes into of our source goes into powering the laser, that's pretty good. So in other words, we usually have to pay 90% taxes on the energy that we use to run a laser, sometimes even more. And it's a good thing our federal taxes aren't that high, although with the way the economy is, I wouldn't be surprised if they do go up that high. But with lasers, we have to pay heavy taxes. Although I understand we have been making some improvements. There's some lasers that are 40% efficient, so we only pay 60% taxes, which still is quite a bit. It would be nice to make a laser that is 90% efficient where you only pay 10% taxes, but I'm not sure if we ever get that high. If we could make 50%, that would be pretty good. If half the energy could be used towards going to the laser. So that's just one of the problems with being able to have lasers like your blasters that they use. To power a blaster, from what I know, you'd need a power source as big as a room in a house. That's how big your power source would have to be, because so much of it is wasted, and that's a bit much to fit into a holster. So what we really need to do, we need to work on efficiency on our lasers, because we pay too many taxes on lasers, let's face it. So any other of you science experts out there, if you have any ideas on how to do that, that would be great, because that's what we really need to do. Also, from what I know, I've heard some stuff about nanomachines, that we can use nanomachines to help us come up with the necessary power to run a laser. But that doesn't help the taxes, does it? So anyway, if any of you guys, anybody out there who has any ideas on how to lower our taxes on lasers, that would be great. Bye.